Hello guys, uh, welcome to the second video of this series. So yeah, earlier we made this project and I called this project as TextCraft Santhos Seeker. It was a pretty big name and it was not, I know, it was not coming up to be my like from the mouth. It was not good. Yeah. So now I'm deciding to like put up a really short and crisp name. So I'm renaming the project to Kenkyu. So yeah, let's change this also. It's Kenkyu. So yeah, recently I started this. I actually finished this game. It's called Sekiro. So people who are not aware, uh, what is Sekiro? So it's a PC game and it's one of the difficult game you will ever play. So it's from the Souls franchise and people who are aware of what is Dark Souls. So these are like difficult games and it makes you question like why are you even playing this game. But once you clear the boss level, it it's feel amazing. So yeah, you will feel like a champion. So yeah, I completed this game Sekiro and I was just thinking of starting off a project which sounds Japanese. So yeah, that's why I'm deciding to change the project name to Kenkyu, and it means research. So yeah, I will just save this. So yeah, in this video series, like in the first video, I have explained over some knowledge graph and some uh, you know, some downsides of what this Llama-index and the Langston's algorithms are implementing. But yeah, in this video I explained like uh, how can we do it better. Actually, I haven't explained how can we do it better, but I simply told like we can do something better in here. So okay, now we have the whiteboard. So the idea is simple. We will be building a RAG application, but it will be mostly specific to the research papers. So research paper, like academic research paper. So for example, if I take any research paper, you can always do, let's say, the popular website, paper with code. Yeah. So yeah, so today this paper is launched, simple testing time scaling. If I open this, I will say this. If I go into PDF, so yeah, these are the research paper, and here you can see like we have multiple sections here like abstract, introduction, reasoning data curation. Okay, something about, I guess. Oh, what was this paper about? Simple test time scaling. Okay, mostly it will be about LLMs and some scaling, how to use our hardware more efficiently. It will be something around that. But yeah, so the idea is to build a knowledge retriever. Yeah, I mean, in any RAG application, we have couple of pieces fixed. Like you have a prompter and you have LLM to answer whatever the prompter is saying, right? But the in between part, which is the knowledge retriever, there it's that which decide how efficient your RAG algorithm is. So yeah, so all this famous what do you get, open source libraries like LangChain, Llama-index, and other, I don't recall any other in this field right now, but I'm guessing there will be more players here. So all of them are like building algorithms around this only. So knowledge retriever. So given a prompt, what's the best context we can extract out of it? So it's basically for context uh, retrieving. Retrieving. So yeah. So our domain is simple. We will be dealing with research paper. Okay. Research papers. Okay. Now, if you open any research paper, for example, this one, hmm, if you scroll down, you will see references. Now, references is something which is common to all research paper. It's something like, so if you guys are in college, like those guys who are in college, they will be asked to do some final year project, and I guess, or if you guys if you guys are more into coding, you might be doing some research already. So references are something which we attach to the paper, and we are basically telling to the readers, hey, these are all the links and the papers we read to create this paper, and these are all the sources from where we got motivations. So usually in college we just put random links there so that we can pass out the final year project, but in actual research field these links are pretty relevant to whatever this paper is addressing. So yeah, so the idea is, given a research paper, we will be joining it with all the references that is there in the research paper. Let's say this is our main research paper, research paper. So whatever references have been given in the paper, uh, yeah, we'll be creating a graph out of it. Okay. Now, how it will help us in answering few questions is basically like, given a question, so uh, we will be getting more contextual benefits from it, because here they will simply explain like, okay, what they have used. But so simply whenever we have a paper, there is always a section which tells about like, hey, in this paper we did this, and because this thing was implemented in this paper, and we uh, did something more efficient than that. So I guess this paper will also have some couple of lines about that, but it's something like, those are simple one liners or two liners. So yeah, so if we read about the transformer paper also, it was attention all you need. Yeah. This was the paper 2017, and this is the base for all the LLMs that we are enjoying today. So yeah, here they have explained the encoder, decoder architecture, the multi-head attention, and they have also explained like, why is it better than all the uh, vanilla RNNs, convolutions, and what makes them better. So we have existing paper of RNNs and convolutions. Okay, they are using their content to tell more like what changes they did that made them better than the existing algorithm. So yeah, but those lines in paper are only mentioned in one liners, so readers will not get a more contextual background, like, okay, this was done, but what was the thing. So those information we can collect if we have some kind of a this structure. So given a question, so we will be mostly collecting the context from the main paper, and it might happen some of the explanations are better presented in the references, so we can use those information to build a better context for the LLM. Yeah, so this is the idea. And for LLM, if you look at my hard drive, so like hardware, I have GPU. It's a gaming GPU like RTX 3060, and it's already consuming 1341 MB. I don't know who is consuming that, but I simply can run a 1.5 billion model. I cannot run a 7 billion model. I can run any like any model lesser than that. Uh, but yeah, either I can go in that way, and I will be putting my laptop in a stress environment, which I don't want to, because I want to use my laptop on a long run. Or I can go with the free LLMs from Google, and that's a Gemini. They have freed their API, so I can use that for the LLM. So yeah, that's the idea. So let's start with creating the project in GitHub. Konnichiwa. Yeah. So let's create a project. Open. Let's go. So let's call it Kenkyu. And let's write a description like, okay, this project addresses the problem of getting, what do you say, getting more contextual information from references of research papers. Yeah, so I have this readme. I need a git node. I will be adding a couple of git nodes, but uh licensing I can put it in as a MIT license, or I can put it as Apache license, so both of them works. Template I don't need. I will be creating my own. So yeah, let's create a repository. uh so yeah, I got this. Now I will just simply clone this git. Let's clear this. Git clone is Kenkyu. Let's go. Okay, so let's go inside the project. So I'm using Conda environment, that's why you're seeing this base here, and I'm using this, oh my, she shell. It's a cool terminal. What do you say, like just like in VS Code you have themes, so it's for your terminal to have more themes, and it can automatically detect your git branches that are activated in the project directory. So yeah, so I'm just telling you all this because of like those guys who will be asking me in the comments like, hey, which terminal are you using? It is for only those guys. So yeah, if you are one of those guys, you can check this oh my Z shell. Yeah, so this is the project environment, and let's start with get dev environment. Get checkout my dev. Okay, I created this new branch. Let's and yeah, I should create a new environment. So get create, let's name it as per our project, Kenkyu. And what do I need? Do I need Python version? I think latest Python version should be good. Yes, please. Okay, and activate Kenkyu. Yep, I have it. Holy fuck, something happened. I cannot run my stock. Boom. Okay, I have to, oh, fuck, check on that. But yeah, let's start off with this. Okay, it's opening. I have this. I should also install Conda, install pip. I don't want Conda packages. I like pip. Here it says small y. What the fuck happened here? Weird. Just Conda things. Okay, so let's do a three-way thing. I'll open this here. I will open you here. Sorry. Okay, here I want this. Here I want you. Okay, cool. So what? I'm in my dev environment, so let's create a entry script by and let's select the Python version. Uh, Cook, no, not Kokoro. It's Kenkyu. Where are you, Kenkyu? Uh, let's switch Python 3. Python 3, yeah. Mm, okay. I cannot find this. I'll just restart my VS Code. I'm here. Kokoro, I don't know how. Kenkyu, yeah, now it's here. Okay. Let's start with hello. Hold. Okay. Yeah, cool. Now let's decide on our project directory. So uh, we have this entry script, and the way I'm thinking of this is, so I will be building some kind of an interface to do it, and so yeah, let's first discuss on that. Yeah, you have this. So we will have a backend where we will be doing this. So given a prompt, it will go to a backend, and once we have the prompt, like the question uh, from the user, what's better, instead of doing this, let's try this here. Let's create another readme. Let's call it uh, decisions MD, and I have this too. Yeah, cool. Let's expand this. Let's close this. Okay. So I will be having my backend, which I am mostly thinking of building in Python. Okay. And for a couple of algorithms, I am thinking of using C++, using PyBind. Uh, yep. Uh, Python, C++. This is kind of optional. I'm not sure if I need some optional benefits. I can go with Python, but I want to try PyBind, and it's simply like you can run your C++ code in the Python uh, interpreter. So some CMake configuration you have to do, and you will be able to do C++ code in your Python. So this I will do if I think I need performance, but for initial POC, I will just stick to Python. Yeah, so I have my Python environment here. Now, what do I need? So, uh, on the client side, so they will be uploading some PDFs. Okay, so yeah, so it's something like they will be uploading a PDF. I will be taking that PDF uh, backend, and this is our black box for the user. Okay, PDF, which is basically a research paper. And once you have this, so your backend should be processing them. Now, processing a PDF, collecting all the references, then collecting the paper out of those references will be tedious task. So I need some kind of a async thing, asynchronous architecture. Okay. Now, if I think it's a performance issue, uh, yeah. So I will need a synchronous architecture so that I will just, so user uploads a PDF. I will not start all the processing there itself. I will wait for some time, and I will just tell the client, hey, give me some time. I will chunk your PDF. I will collect all the references. I will build the context retriever. Once it is prepared, you can check on me, and then you can use it. So for that, I will be doing a asynchronous architecture. So uh, mostly I'll be coding in Fast API. So Fast API has a inbuilt async mechanism. So we call it background task. Uh, background tasks. So this is something I can use for initial POC, but a better architecture will be let's celery plus Redis. Yeah. So yeah, this is a popular architecture for asynchronous processing. So I'll just start off with background task. But yeah, sooner I will be moving out to celery. So okay, now let's assume I have written my code. I have my asynchronous architecture. I have all the modules in place, which can take the PDF, do all this thing. Okay, then what I need, once that is prepared, so the user will be selecting which one to run. So yeah, so normally what will be happening is, so if I have an interface, okay, where I'm giving them the option to upload PDFs, okay, now I should have table a table kind of a system, or something kind of a dashboard, you can say, or dashboard. Okay, so where they can keep an eye of which paper is currently being processed, and what's the status of it. Is it started, it is pending, or it what stage of it is currently now. Okay, so something like this, we generally call it a jobs table. Okay, jobs table. Okay, now the reason this is for upload. Yeah, so we require a jobs table because you are making a promise to the client. Hey, just upload your PDF. I will not do it immediately, but I will do it. But since it's a client, it's a human being, he wants to monitor it. Like, you have made the promise, but I want to see the progress on it. It's not like I can give you 10 years of time and you will be like doing after that. So in order to give the user the ability to monitor on their uploads, we require a jobs table, which has some metadata thing here. Okay, related to what have they uploaded, at what time they have uploaded, all those things. And the main thing is the status here. Okay, so let's say the uploaded file entry is here. What's the status of it? Is it like active, pending? Okay, and if it is completed, did some error happen, or everything is good, you can use it, sir? So yeah, that's for that. So uh, yeah, so this will be covered via my asynchronous architecture. Now once I have all this thing ready, now if everything went well, they are at the success position. Now what do I need? So if they are at success position, so they should be a I should be giving them the retriever for that paper. Retriever. Okay, now I have to initialize that somehow, so that from the user session they can use this retriever, and if they go back to the some other page, then again initialization will happen, and they can chat from it. Yeah, so I need to provide a chat interface. Chat interface, yeah. Now this retriever initialization has to be happen, because it's something that this retrievers will be kept in some kind of a database service. So yeah, I need a database service. Database, yeah, database service. Now once this activity is success, I want to load the retriever, and the loading should happen. So somehow the user should be able to see, hey, it's retriever is being loaded, so I should wait for a couple of times. So some kind of loader will be visible in the UI. Now once it is done, the retriever has to be alive in the session. And session basically means like, since okay, it's similar to like for those people who are not aware of what sessions are. So normally, if when you visit let's say I go to YouTube, so I'm in my session. Okay, so whatever activity I am doing, so while I'm logged in, all those things are being monitored, and based on my activities, some recommendations are happening. My searches are being saved, my history is being saved to the database, my liked videos are being saved. So all those activities are being done in a particular room, and that room we are calling it session. And we get out of the session when we log out. And yeah, that's the thing. And if you go to your web browsers or anything, you will also uh, find some kind of a session storage, which basically stores all your content. So for example, this is YouTube for me. So yeah, all this thing you will figure out from there. And yeah, so all these websites save some data in their session storage, so that yeah, they can use that information later for their other recommendation and for other product services. So yeah, that's session for you. Now the retriever has to be loaded inside the session, and once it is done, I should provide a chat interface. Now building the chat interface will be yeah, will be with respect to how I'm initializing my retriever. Because if I normally go with a HTTP type chat interface, I might lose my retriever initialization. Yeah, I might lose my retriever initialization. The reason being, because HTTP request, so they will send a request, I'll be doing something, and that request session is gone, like the TCP connection is closed. And once that is closed, it will close down my retriever. So in order to avoid that, I can use WebSockets. Okay, so as long as my WebSocket connection is there, it's alive, my retriever will be alive. So that's a easier way. Now with HTTP, I can do, I can decouple, if I can decouple this retriever to some other group, like uh some other environment kind of, then my request and response will be like closing, like opening and closing, like those TCP connection will be closing and opening, but my retriever will be alive at some other place. So similar to like how we deploy models in production, so your models are always alive. You are making a connections request to your backend, the backend is calling to your model, and then the model prediction is being pushed from the backend to the client side. So your model station is always alive. Your backend is just like opening and closing the client's connection. So yeah, then for retriever, I have to use some kind of a pool service where it will store the list of my retrievers. And this will be kind of hectic because if I go via this path, then again I have to manage how many retrievers I can have at a time. It might overload my RAM. It might crash my backend. It might, depending upon the size of my retriever and how much memory it is consuming and how efficiently I'm writing the algorithms for the graph traversal and retrieving the context. So all those will be kind of related to the maintenance of the pool. So if I want to take a challenge, I can go via this path, or I can make my life easy and don't take any stress by using WebSockets. And I think WebSockets is my way. And yeah, this is my VS Code. So database service to, yeah, I have database service, then I will be using WebSockets. Yeah, I have my socket, so whenever my socket connection is established between client and server, they can communicate between each other. On the client side, they will be sending prompts. On my server end, I will be having my LLM and my retriever all initialized to communicate, like to answer all the user questions. So yeah, WebSockets. Cool. Any other thing I will be needing? A couple of other things I can do, like if I'm able to show them the visualization, like how their retriever is looking, that will be a good idea. So I can put some kind of option thing. So how retriever visualization, retriever visualization. Yeah, which is kind of option and don't really necessary. It will be for a normal client, they don't like need what's how their retriever is looking, because they don't care, they just need to find the answers of their questions, right? For some couple of who are into programming and they want to see how the retriever is uh, looking, they need this. So yeah, I guess this is all the things I'll be requiring to build this RAG application. This is on the application side. I haven't covered on the module side and how I will be using that, how I will be creating that. But I guessing I will be able to figure out a more Python library that can take all the sections and images, text out of it, and some kind of a script. Yeah, got it. Yeah, I should. Yeah. So we have this, right? So from this paper, we are going all to the references, but we need to somehow get the links for those references. Now, once we have those links, we have to script the paper. So we will have a couple of more PDFs here. Yeah. So scraping is there. So I can put 5 as a priority. Scraping of reference papers. Yeah. Yeah. To do that, I can launch some green threads and they can do this task, or I can simply use a async IO thing. Just to collect the papers, not to run the processing part. Mm, what are the things I need? Hmm. And yeah, some kind of a prompt maker, which is essentially a experimental part. There is not much mind we have to uh, indulge in, because simply prompt we just have to make some prompt. Just write it, because as per like LLMs, prompting is very essential. I will just write it down, but we will like in the future we will not be seeing all this prompt engineers, right? Because as our LLM is like making more and more progress, we will not be requiring specific prompts for them. Prompt, like, since the LLM performance is increasing, they do not require specific prompts for their work. They will be able to work in any prompt, and that's the idea behind improving the LLMs, right? So I don't really give any like credits to all prompt engineers. No offense, it's just my perspective. So, some kind of a prompt engine. Yeah. So you have this, and yeah, one more thing to also to consider, like when I have this main paper, and I have all its references. Now, it might happen all this reference paper will have their own references, right? So, but the key thing to consider here is, so as you are going more and more deep, you are somehow losing the semantic relationship between your main paper and your child reference paper, because all this paper will be written to explain this, and this is being used to explain this thing. But as you go more and more deep, these will lose out, like these will have weaker relation or lesser semantic relationships. So yeah, so depth is something we have to consider. So we can stick to like one or two, but yeah, more than that, I don't think we will get any benefit, and I don't want to do all that processing, because you can see like in one paper we will get around like 20, 30, or maybe even more references, and as we go deeper it will be like 20 to the power of more 20 or 30. So I don't want to process all those papers. So yeah, this will be like this is how it will be. So yeah, so we have backend. Let's look at how it looks. Somewhere here preview is there, right? Open preview. Yeah. Yeah, so I have backend prompt engine. So yeah. Now let's take a look at the front end. So let's go to the standard front end framework, and that's the only framework I know. I don't know any other front end framework. Uh, it's not a framework, it's basically the library, and I guess most of you will be figuring out. So it's React. So yeah, I know React. So I'll be sticking to React, and just that. So I can't say any other thing in front end. So I only know this. So React for front end. That's it. Nothing. Cool. Now, for database services, I can use some kind of a Postgres kind of a system, or I can go with Mongo. Uh, Anything is fine. But let's make everything structural, and let's do Postgres. So since this is kind of a POC kind of a project, so let's not think anything. So let's stick to basics. So Postgres is the one we will be using. So we have Postgres, we have WebSocket, any other DB services I will be needing. So yeah, so if I go beyond, so if I see the requirement of scaling my async architecture, then I will be moving to celery plus Redis kind of architecture. But if I don't feel the requirement, I will not do it. Yeah. So yeah. Mm, so that's all the things. Uh, so let's start off with some project structure. Where is it? Yeah. Let's close this. Cool. I have this. Now let's create SRC. Okay. Now inside SRC, so let's first install actually fast API. And before that, I can also create requirements.txt, which is like heart of every Python project. So let's install fast API, and I'll be installing everything from fast API. So all flag for that, and it doesn't work because it doesn't like it. Now it should work. All those logs. Yeah. So yeah, I installed fast API, and if I do it show was it, please provide a package name or names. Uh, fast API. Yeah. So I have this, but I can simply do fast API. So I need the version of 115.8, and it should have also installed UVCon. Yeah, so pip show UVCon. So I have this. So UVCon 3.4.0. So yeah, Fast API is a framework for building backend services, and UVCon is a gateway that handles incoming requests and sends it to your backend service. So that's that. So yeah, and UVCon is kind of a scaler, you can say, for fast API here, where you can mention one kind of workers you will be needing to run your backend service, how many workers you will be needing, and workers here mean like so there are a couple of workers. So there is like unicorn workers, UVCon workers, which can handle async work, and we can give some timeouts, all other cool things to manage your backend service. So yeah, I should not say all this stuff. So yeah, I'm just saying. I don't know why, but yeah, there is fast API, UVCon. Then what else we need? So to process PDF, we can install this library, what we call, yeah, this one, PyMuPDF. So I was going through their documentation, and there's a lot of things they are offering. So they have also this PyMuPDF LLM and RAG. So and LangChain also uses it. They just directly use this PyMuPDF loader. So it's one fact I hate about LangChain and all this Llama-index library is just simply like they are kind of a compilation of multiple Python modules, and they have not written their own algo or something to parse or do this. They are something like a compilation. Okay, it's a compilation of all of these modules, and because of this, installation of all those packages are also difficult. So they have different pip installations for different processors, and even for models and for retrievers they have different pip installation, which I don't know why someone will need that. You simply be very subtle to install only pip install langchain or pip install Llama-index. But no, they want different pip installs for different things, which I don't know why. So let's stick to go to installation. I have installation. You are creating environment. You are upgrading pip. Then you need to do this, which I will do here. Done. 20 MB, and it's done. I'll simply do pip show. Uh, PDF. Yeah. Now, a couple of you might be thinking like, why the fuck I'm not using Toml or that poetry thing? Because I don't want. That's difficult to manage, and yeah, I just don't want that. So requirement.txt, peace. So yeah, I got this PDF parser, PyMuPDF, and what else I need? Database service, Postgres. So for that, I think I need SQL model. Yep. It comes with that juicy Python syntax which we can use for validation so that we do not need to validate. So how to install you? How to install you? Oh yeah, oh simple. Pip install SQL model, and I think it automatically install as SQL Alchemy, so which is a good thing. It uh yeah, runs 0.2. Cool. So we got fast API, UVCon, PyMo PDF, SQL model. That's for our database service. And yeah, what else we need? Hmm. LLM. I forgot about LLM. Yeah. Reading. I don't think. Yeah. Decisions. What changes I have done? Okay. Only this. Cool. Prompt engine and it one is LM. Yeah. And for that we will come later. So whether I will be installing like running some model on my local uh, or I will do something else. Yeah, I'm pretty curious why stop is not working. I will just simply stop. It's pseudo installation. Yeah, sudo apt install stop. Yeah. So recently I was installing CUDA and for some reason I have to install systemd, and this was like that was something which was not coming with WSN installation. So I was installing that. Maybe in between I somehow like remove htop. Now are you working? Yeah, you're working. Cool. Okay. I have you, and yeah, cool. So let's make a directory structure. So I have main, So I do not need you. So here I'm saying src factory import. I can do this. Give more space to my VS Code. And yeah. So create app, and this will be creating an app probably. Okay, now here I need to create a init file, init py, then have to create factory.py. That's will which will create my fast API instance. Fast API import fast API, and yeah, good. And I also need, I forgot. But yeah, I forgot all that. I'll see the documentation for that. But yeah. Um, what was create app, or let's name it yeah, just create app. Okay, create app sounds cool. I have this. Now this will be returning me a fast API instance. Okay, now here I will be saying fast API, and somehow here it takes what's my name of my application, right? So I will just simply call it Kenkyu, Kenkyu, and I need one more thing, which is this thing, version info, which will monitor what's the version, and this will say what's my version. Okay, and this is basically related to your project uh initial app setup. Yeah, and I just need to know whether I can use this or not. Python import os or list here. Yeah, it gives me this. So if I simply open this, as I'm just checking whether I can put this file as it is, or do I need any other thing. Okay, so read. Okay, I'm getting this, which is cool. Now if I do a little JSON and use the same thing but with JSON load, and cool, it gives me the JSON back. So I can use this, and I can get the version from here, and that I can give it to the API. So here let's write import JSON, and collecting version info from cool. So where were we? So collecting version info. So I have JSON, so let's call it version mapper JSON dot load open. So you should get it from the root, and once you have this, so version mapper. Oh fuck, yeah, so version num. Cool. And it also takes a description, right? So version mapper description. Cool. Uh, so I have this. I have created this app, and one more thing I need to figure out is this thing, fast API box. Uh, so it's pretty standard thing. So middleware, fast API middleware. Oh, it's not course middleware. I have this. Let's put an app. Okay. Instance. Create cross origin resource policy. So people who are not aware of this cross origin resource sharing, we call it sharing. So what is this? So basically your browser disallow the data from all of the services. Okay. Whenever there is some two different platforms trying to exchange data in between them, they cannot do that. So it's because of this cross origin resource policy, we call it CORS, cross for C, or let's write it like this, CORS, and we will just sure CORS full form, whether S stands for sharing. Oh yeah, stands for sharing. So yeah. You have cross here, you have origin here, and you have resources here, and you have sharing here. So as per the name imply, you have cross origins. You do not have the same origin, so two different stations are there, and they want to exchange data. So just like your browser and the server you want to reach out, okay? Those two are different. Those two are at different places, right? So your browser is in your laptop or even in your phone, and the server is somewhere in AWS or GCP or Azure or some other cloud platform, right? So those two are different. So usually it's not allowed that they can share data. So somehow in order to bypass that and to tell the server that hey, you can send data to this client, you should trust it. So we put this CORS policy. So if you check out the config, so let's close this. Yeah. So since this is our backend framework, okay, I'll be adding this thing. Okay, integrating CORS. So these are all the IP or like addresses which I want the backend server to neglect. By neglect, I mean like to accept data requests from all this. So yeah, then so app middleware, you have this. I will be saying this allowed origins say or then allow methods all, then actually I don't know, need a separate variable for this. Then allow headers. Look at this. Cool. Now I have integrated this. One more file I need to create. It's routes.py. So in any fast API or any backend framework, so we always have this router, and it acts as a proxy between different endpoints. So you just write your slug, and there is a middleware slug handling all the. So yeah, so for those people who do not know this, so for example, mm, okay, I can show you something like that's a good example. Let's go to Wikipedia. Let's open this. Let's maximize this. Wikipedia, and let's go to, let's say, L. Okay, so here you can see this thing now. So so in the first you have the Wikipedia address. Okay, then you have something weird, this slash wiki, right? So you are going to the wiki directory, and then you are going inside the LLM file. So that basically means this. So here our router will be our wiki, and LLMs will be the functions or the endpoints for doing the tasks. So I'll be writing a router here, and this will take my API router. Now I will add a default health check router here. So router, which I can perform a get request, and it should I'll check, and it should return me a string kind of a response. So endpoint for handling health check, and what I can write. So voila, I'm alive. So yeah, this is one endpoint I have created. Okay, now I have this router here, and somehow I have to integrate it inside my app. So in order to do that, let's move this JSON to the bottom. So let's import fast API. Oh, not here. So that's in my SRC. Where did I create that routes? Oh, routes. Okay, I went. Oh, okay. Factory needs to be here, and init needs to be in here. Then this route thing also has to be here. Yeah, now it should work. Routes import router, and integrating router. Cool. And here I'll be saying API dot add router or something. What do we call it? Include router, yeah. Include router, and we passing this router. So whatever routes this router has mapped, I'll be integrating to my app instance. Cool. I have this, so I can write function to return a fast API instance. Cool. So have this, and couple of more directories I'll be needing. So let's look at our tree. Cool. I have this structure, and one more thing I need to create is inside SRC I have to create utils. Create, yeah, I have utils here, and inside here I have to create config. Okay, now I have to create this config here. So all the application level configurations like environment variables which you want to use across some projects, or some kind of config like API keys or some directory names, something like that. All those things will be written here. So yeah, we have config here, and one more thing we need is the helper.py. So some common functions, we'll be writing it here. Okay. Then once we have this, we will be needing a database class. Okay. So again, a init file will be needed here, and actually I do not need an init file here. I can import it from src itself. So database, so here I'll be saying database, database file. Yeah, so here this will be writing my database bus. Cool. So I have this. I also want to check if Docker is running. So Docker is not running. Docker desktop. 1, 2, 3. Okay, it installed. Cool. While my Docker desktop is loading, I can. Okay, it's done. Docker PS, Docker PS, Docker PSA, Docker PSA. Okay, I have some MySQL thing running already, which I don't need, but yeah, cool. I have database first. Let's start spawning our fast API first. So we have tmux. Yeah, I have tmux. So control B, and I forgot what to do here. So yeah, control B, percentage this. Control B, percentage this. Yeah, cool. And let's start our Unicorn server here. So and I'll be saying host 0.0.0 to port 8000, and boom, gone. Oh yeah, I remember. So that was version description, right? So where is version config? So it was version description. I can close decision, this preview, config, factory, database. I do not need. I will be implementing this. So yeah, it requires this. And why does hot reloading doesn't work? Here, I have given reload thing, right? Cool. And I'm not seeing the page. Interesting. If I do okay, I'm getting it here, and this is my WSL environment. But my Windows cannot access this. Okay. Hmm. Why? Will this work? It's taking time. So, but I don't see any request here. Okay. Let's look at my IP. I have this thing. Now, if I do this docs CDP, and I got this. Cool. So I have this, and I can check this out, and it say voila, I'm alive. Nice. Cool. Let's close this. Yeah, I have this. Cool. My fast API service is working. Now I need to figure out how to build that service. And to conduct those experiments, let's create a notebooks directory. So let's create a notebook here. PDF parser. We Let's select our kernel as, I don't know what the fuck it's saying. ls. No, I don't want to use REPL. Select another kernel. Python environments. Kenkyu. Yep. It should tell me to install IPythons. Yeah, it's install. Okay. Loading. It's just loading. I don't need you. Let's check. Okay, I've already recorded 1 hour 11 minutes and I haven't done a single like significant progress. Yeah. Okay, I think it's done. Please take a minute to tell us about your notebook experience in VS Code. No, thanks. Cool. So I have this. So I will check if I can import PyMuPDF. Uh, I don't need you. I don't need you. I do not need you, right? Right. I do not need you. I do not need you. Yeah. I do not. I can close my channel here. I can close it here. And yeah. Oh, at first, let's push our code. Not get push. Yeah, let's not get push. Let's look at all the changes we have done. Oh yeah, I forgot to add a git ignore. Let's add a git ignore. Git ignore. So let's look at Python git ignore. I need this and build eggs. What the fuck is eggs? Wheels. Nope. So C extensions. Right now I do not need it. Distributions. .python build dist. Where it's mostly PyCache file that we should not push it to GitLab. It's just like some cache files it creates, and it holds those Python files. Log db this. Yeah. So ignoring notebooks, and we call it notebooks. Does it automatically take care of that? I guess it automatically takes care of. Get what do you call it? Status. Yeah. Yeah. Cool. Anything I'll be needing from here? Yeah, I can put envs dot when, let's say in future something changed my mind, not to use conda and to use env or a dot vnv. Like since this so this uv package is also becoming popular, right? So that rust package for uh, python package installer. Yeah, uv python package manager. Yeah, astral s. Yeah, which is pretty fast. It also does your poetry thing. Yeah, but it's kind of new to the market, and I don't know whether it's reliable or not. And And also, yes, you guys can argue like, hey, I'm just starting off a new project. Should I be also thinking about that? Just no, but it's just my OCD. So yeah, I will just stick to requirement.txt. Yeah, cool. So I have readme getting no decisions.md, main requirement.txt src version info config. Yeah, cool. So I will just add everything here. I will just commit. And what should I say? I should say update initial commit. I need to set this up. Config. Uh, let's take my mail. I get if origin dev. Cool. Now I should see dev here. Huh. Oh, I was not able to commit. Yeah. Uh, Now it should appear in git log. Yeah. Dev. Cool. Nice. Cool. I think this is for main. Yeah. I'll not touch master for now. I'll just create an initial POC for it. Then after that. Cool. So I have this. Then what do I need? Yeah, I was working on the PDF parse thing. And then deleted PyMuPDF. Uh, PyMuPDF. So yeah, the idea is how we want to build it. Yeah. Yeah. First, let's see what all functionalities you can have. Basics. Okay. You have this. Let's first have a paper first. So let's start with attention. All you need. And take this paper and try here curl this open attention paper. PDF, does it allow that? Ah, it allows. I got attention paper. Nice. Can I open that paper? I don't know. It doesn't work here. Where are you, VS Code? VS Code? VS Code? Oh yeah, there you are. Yeah. So I have this paper. So let's move it to notebooks, data. Have to create this directory first. Then I will move this attention paper to notebooks and data. Cool. And for this, I'll simply check. I'm here, so I need to go one level back so that it will be here. Then and I can do something. Importing modules. Cool. Then I need PyMuPDF, and after that it says doc. Let's PyMuPDF open, and let's create file paths. I'm already out of that, so oh, what the fuck I'm thinking. I can simply do this. Oh, it's marked down. Click on, have this file path. Okay, I have this, and so I can now iterate over it. For page in doc, uh, let's print page. Let's break it down. Okay, so it says page 0 of notebooks data attention PDF. Let's look at the paper first. I am in side project. Yeah, I'm in side project. I'm in Kenkyu. Data attention, all you need. Cool. So yeah, the paper is there, which is good. I think, yeah, get text. Ah, nice. Okay, we got this. So up to here we got. Now what do I need? I need to get to that reference thing. Oh, it automatically comes with the number of pages, just like the number of pages it has. Okay. So I can say num pages total len of doc. Okay, that's the number of pages. Then just takes the page, takes get images if the page has any images. um hmm so what I need is to get section level things. Attaching file, embedding file, editing pages, rearranging pages, copying pages, selecting pages. Adding blank pages, inserting pages with text content. I don't want to insert anything. Spreading pages. Okay, combining single pages. Encryption, decryption. Ah, that's a cool thing. Extracting tables from a page. Nice. Okay, so per page, I have to extract text, extract images, and then I have to extract tables. What else I will have? I have text, images, tables. Cool. Now I'm just yeah, I'm just thinking how will I get section by section content. How to get section wise content in PyMuPDF. I hope someone in Stack Overflow should answer this. Extract text from PDF page by page, line by line, blah blah blah. There is this. Let's look at the Medium article. Okay. I mean, I can iterate over all the pages and I can check whether a line has reference there. If it has reference, then it means after this position, all of the content below it in the single page will be references. Yep. And it might happen that references is at the top. Okay. And you have all the rest of the links here. Now, another case might arise like your references are somehow between in the left, but at the bottom, and on the right, you have all the links. And to tackle that, that will be a little difficult. Will it be difficult? I have to check. But yeah, it says get text blocks. Blocks. Is that a thing? Blocks? Oh, this block means my answer? This block is the thing that I'm looking? Is block the thing that I'm looking? So if I look at that again, where are you? Attention or attention people? Yeah. Let's see. Let's go down. Okay. Here have attention. But yeah. Okay, so I guess block is the one that can help me here. It simply gives me. Let's try it out. So I have text here. So page get text and you are seeing block here. Now if text or I can say references in text, that's my page and I will print that. And I will click it there. Assertion error. Assertion error. Okay, I guess it gives something else there. I have to give blocks here, not block. I didn't find anything. Okay, let's look at which page. It's there at page 10, right? So IDX or page index, that's this, and enumerate. Now I can simply say get the text if page IDX equal to 10. Okay, let's go check this. I have this, I can remove this and I can do this. Let's look at the text here. Let's do pre-deployment installation. Okay, let's look at this here. Okay, cool, I'm getting something here. Then okay, this is a pretty weird syntax that for a block in output. I'm not sure what that is saying, but it's something like, let's look at what does it say. So I will say for texting output, does it work like that? And I say this, I'm getting this. I guess this is the coordinate of that, like the bounding box coordinate of this passage. And yeah, so how does this look like? Okay. Phew. Okay, guys, I guess it's getting late for me. So yeah, I'll be mostly trying to complete this project, and yeah, I just hope you guys learned something new from this video, and I'll be uploading more videos on this topic. Just stay tuned with me and let's complete Kenkyu together, so that you guys will learn, and you guys can also comment me if I'm doing something weird, or like you guys can comment me so that I can improve myself. So yeah, just stay tuned to watch more videos. I know I have not been uploading videos because of like I was in some office project, so that was kind of hectic, and today I got some time. I thought like, okay, maybe it's the time to create some video. So yeah, I just worked on this video. Uh, yeah, I will be uploading more videos on this topic. So yeah, thank you all for watching.